Hey, good afternoon once again. I'm Joshua Santora, and I'm coming to you live from the Kennedy Space Center. Obviously with the way things are these days, I'm coming to you from my house, but still talking about some amazing work happening at America's Spaceport, as we like to call it. Certainly the spaceport that has the most epic history in history. And so we want to talk today a little bit about things that you can be doing at home, believe it or not. So we're talking about growing plants from popcorn. So you might be asking yourself, number one, how do you do this? And number two, why is NASA concerned about this? And we will get to that in just a minute here. But first up, we want to make sure we highlight the fact that we are a spaceport and we are open for business. Specifically today, we are honing in on the research and technology arm of what we do here. So we're involved with space station activities as well as some really interesting research happening here on the ground to support exploration. Let's jump right into it now. So I'm going to go ahead and bring over my guests. I want to introduce to you first Gioia Massa. Gioia is a life sciences project scientist. Gioia, thanks for being here.
Hi, thanks for having me.
Yeah, and we also have today Trent Smith. Trent, how are you doing today? Veggie project manager and self-proclaimed nerd.
Doing great. Thanks for putting all this together, Josh.
Yeah, absolutely. So we want to jump right in here, and we'll get to the how do you grow popcorn yourselves at your home in just a little bit. But let's talk about, why does NASA have plant scientists at all?
Well, Kennedy is really the plant center for the agency, in addition to being America's spaceport. So we have plant research going on here for a couple of different things. We have people that look at fundamental plant responses to their environment, and they use space to understand how plants can sense and respond to things like gravity. But what we do, what Trent do, is more applied space crop production, looking at how to grow food for the astronauts in the future.
Trent, from your perspective, what are we talking about when we're talking about plant scientists? We're trying to learn things and grow and get smarter for the purpose of exploration. So what does that look like? Why are we doing this? What are we learning?
Well, you know, when we go to Mars, we're going to need to grow some of the food to supplement the nutrition. And so right now with Veggie on Space Station and the ground research that we do at Kennedy, we are learning right now just how to grow and eat plants. So, you know, it's really about the stepping stone approach to growing plants on the moon and then Mars for astronaut nutrition.
So can you talk a little bit about this picture? We talk about growing plants in space. So what are we looking at here?
Yeah, that's Steve Swanson, an astronaut who first installed the veggie chamber that we have along with Rick Mastracchio, and then grew the very first set of lettuce in Veggie. So she's our small plant chamber on the space station. And this was the first time that we had grown these lettuce plants in Veggie. And Trent and I were pretty darn excited by this.
Yeah, that Swanee, he was such a pro. When he harvested that crop, I mean, if you look at the photo, there were only 3 plants, but we had 6 plants that we had hoped to grow. So we were only 50% on that one. But that was our first time ever. So, you know, a lot of times when you bat 500 your first time, it could be a failure or it could be a success, depending on how you look at it. But you still have a smile on his face. And they were real excited about the harvest. That harvest, there were 2 astronauts there and even a cosmonaut. So it was a big deal for the crew.
And when we think about just the nature of that, you mentioned kind of 50% being good for your first time. Most people hear that and they might not understand why that's true. So for you and I, we understand that life in space is different, but for those who may not really kind of be able to kind of wrap their minds around why is it so different to grow plants in space, what are some of the challenges that make this so challenging? Trent, let's start with you and then Joy, over to you.
Right. Yeah. Really growing plants in space is really difficult because of watering, right? When we water our plants here, like around in my house, I go to the kitchen, I fill up my pitcher, and I just water them, right? And the water drains down. But in space, when to water your plants, first of all, you need a pot to hold your dirt, even if you use dirt at all, right? We're studying ways to grow plants, like we do on the ground hydroponically, but you can't really, it's more difficult to do that in space. So we need to contain the dirt, we need to contain the roots, and photons don't care about gravity, but water does. So when we grew those plants, we weren't sure how the watering was going to work, and that is why we lost 2 of the plants. And actually, with that experiment, we had 2 seeds in one of the pillows, and that one didn't germinate at all. So it really illustrated a lot of the issues we're going to have growing plants on Mars and the Moon is watering your plants, and then seed germination, and then of course keeping the plants healthy. That was things that we learned later. Gioia, what do you want to add on that?
Well, I mean, I agree with Trent. I think the watering is the biggest challenge. And, I think we have a really good video that you can show of Commander Chris Hadfield bringing out a wet washcloth to kind of illustrate why this is such a challenge. So, he's adding water to a cloth, and he'll get this cloth really, really wet, and then he starts to wring it out. And this was actually an experiment designed by school children, and it's a brilliant experiment. So you see this really wet cloth, and as he squeezes it, you'll start to see this film of water coating the edges of the cloth, and it gets thicker and thicker, and the film of water it's a tube of water around that washcloth, and it starts to crawl up his hands and coat the surfaces. So you can see that. And if you think of that washcloth like a plant root, the same thing is happening to your plant roots. And the reason that this is important is because plant roots need air. They breathe oxygen. They have a process called respiration, which, it's similar to our process of respiration. They need oxygen to keep the cells alive. The shoot also, but plant shoots also generate oxygen through the process of photosynthesis when the lights are on, and they get oxygen from the air. But in the roots, when you have that much water, it's really hard to get the oxygen into the plant roots. And so your plants are always either getting too much water in space or not enough water. And then you have problems with roots. And if you can't have good roots, you can't have happy plants. So I think the water issue is one of the biggest challenges that we're dealing with so far. Plants in general seem to adapt pretty well to other aspects of the space flight conditions, as long as you have things like fans to move the air and lights to guide the direction of growth.
So kind of a segue here. This is obviously kind of some of that beautiful just plant growth in space. Obviously, we saw some lettuce earlier, which is great for nutrition. This is not so good for nutrition, but what's the value in seeing a flower in space?
So I'll take that and then Joy, I'll just add on. I just wanted to mention that the flower was really one of our first ornamentals, and it was the first ornamental in veggie. And the flower really the flower, though, you need a flower to produce fruit. So if you're growing tomatoes, if you're growing peppers or anything like that for vitamin C or any other nutrition, you'll need to get a flower then a fruit. So that was good. Joy, what more do you got to add on that?
Well, yeah, we were able with those rosinias to show that you could grow the plants for long enough to get them to flower, and Scott Kelly did that experiment, and he did a wonderful job saving those plants. We had some problems with water and with airflow early on in that experiment, as Trent well remembers, with lots of really early morning calls from the space station. But when they started flowering, it was also this thing of beauty, and I think that was something that we didn't realize what an impact that would have. But Scott actually made a bouquet from the zinnias that he harvested, that he grew. There were enough flowers, and it was the first time there was a flower arrangement in space, and so I think for me, I felt really humbled to be a part of generating something that was art in space as well.
So thinking about, obviously we're getting better and better. We're learning more and more about growing in low Earth orbit. But for NASA, we have our eyes set on the moon with a vision for Mars. We have the Artemis program. So what are kind of the future challenges as we look to move beyond a platform that certainly we haven't mastered yet, but that we're good at? What's next for us? Where do those challenges lie in being the best at this throughout the whole solar system?
Well, we've started with lettuce and leafy green crops, and we're figuring out how to understand the food safety of those plants as we grow them in space, because food safety is really important, and just as it's a challenge to water your crops, it's also a challenge to wash your vegetables, right? It's even hard to wash your hands in space. And so we have to understand how to keep the plants clean and safe to eat. Here's a wonderful shot of Jessica and the other astronauts having some Mizuna mustard recently on the space station, which they mixed with the packaged food and seem to really enjoy. We're also working on, solving the problems of watering, selecting new crops for space. That's another thing that we have a lot of work going on here at Kennedy Space Center and around the country with students helping us, and I can talk more about that later. And then we're working on designing the growth systems for the future. For something in space, in microgravity, space to grow is pretty limited, and so we have to keep these growth chambers small, but we want to get high yields, we want to get a lot of productivity, we want to get a lot of food out of it. Maybe when we go to the surface of Mars, we'll have more space. I think you have a picture we can show of what a Mars surface chamber might look like. That's something, where we would love to have an ability to really grow enough food to supplement the diet for a crew that's living on Mars. So this is an artist's concept, but it would be a really exciting thing, if we can get to that point. And we have to get to that point. The prepared packaged diet, and I think you have a video showing what the packaged diet looks like. The astronauts that are eating this, they eat pre-packed food. They enjoy it. Meals are a really big deal in space. All of the food's actually really good. It gets very high ratings before it gets sent to space, but everything has to be stabilized or freeze-dried. They add water, and that diet, while really good, may not be enough for something like a trip to Mars, because when you store this food, the vitamins and the quality degrade over time. And that's not an issue on the International Space Station, where they're getting new food every few months. But for a trip to Mars, that food may have to be sent ahead and maybe sitting on the surface of Mars when they arrive, the food for their return journey. And if it doesn't have enough nutrition to meet the needs of the astronauts, we have to figure out a way to supplement that diet with fresh vegetables to provide that nutrition so that everybody can be safe and healthy for the trip to Mars and the journey home.
Yeah, right. So I want to actually come back to something you mentioned, Gioia. I would love to talk about citizen science a little bit. Trent, if you are there, I think you might have frozen on us for a second, but I think you're back. If you can talk about some citizen science efforts. I know that we have some really cool collaborations with students across the country. And then let's dive into this popcorn challenge, because we want to deliver on that. Let people know how they can be growing plants from their popcorn at home.
So I just wanted to mention that, Gioia talked about the benefits and the reasons why we're growing plants. But, and she mentioned the technologies, right? You got to clean your food. You need to be able to grow your food, and if the plants get sick, well, then you need a way to detect that. So there's a number of technologies that we're developing so the astronauts can go, do what they need to do on Mars, all the science that we want to go do. And hopefully you have robots and sensors helping to grow the plant. And, it's not just us. There's actually people all around the country working on this. And part of the team helping us select crops and figure things out is, the Fairchild Challenge. So we had this year, I think more than 200 schools, I'd have to check that, but I think more than 200 middle school and high schools all across the country growing plants for us. And, the type of plants that we need right now are compact. They need to germinate reliably, they need to grow fast, and they need to be robust. So, you could think if a plant can grow in 50 different classrooms and all these different conditions and microbiology kind of going on in these different classrooms, then that's probably a pretty robust plant. And so we have just thousands of student citizen scientists across the country growing the plants, collecting the data, and putting it up into Google Docs. And we, along with the statistician at the Fairchild Tropical Botanic Garden, get to look at the data. And, we actually flew plants that were first identified and tested by students. And so for me, it's so exciting to go look at Twitter, because they're all posting on Twitter I think it's at Grow Beyond Earth. So as part of the Fairchild Tropical Botanic Garden, thousands of student citizen scientists helping us select the next set of crops. And that was really, really terrific. And so, I'm hoping that more people can figure out what, help NASA do this. And some of the plants we're looking at are also known as microgreens. And microgreens are just young plants that you can grow, and you grow them as a lawn. And they only take, most of the time it's about 10 to 20 days, maybe at the longest. And you can actually produce quite a bit of food. And the microgreens are actually typically more nutritious than the fully grown mature plant. And actually, I grow microgreens at home just for fun and with my kids. And when we talked about the popcorn challenge, I went and gave it a try. And, you can grow a plant from popcorn. I was shocked.
Yeah, and I want to say, Joshua, too, that the Growing Beyond Earth program at Fairchild that Trent mentioned, where we have these, hundreds of schools, also has another component which will be announced via Twitter on Saturday through this NASA at Home, and that's to design a growth chamber. So anybody who's watching, can design a plant growth chamber for space, draw it out, send a description in, and we get ideas this way. We've done this with elementary school students, and we've got some really amazing ideas, and some of the concepts we've actually started building either at Kennedy Space Center or in the Growing Beyond Earth Innovation Studio to test out some of these really innovative concepts. So we need everybody to help with this. There are a lot of challenges associated with growing plants in space and feeding our astronauts in the future. So we really can use your help.
Yeah, so let's jump in here now. So while you're thinking about the design for a plant growth chamber, here's something you can be doing. Again, as Trent mentioned, we're talking about you can have products here in 7 to 10 days. So take a look at this.
When we were looking through our pantries at home, we thought, what do most people have on hand right now? We thought, hey, we could grow popcorn shoots for this challenge.
You choose your container. You calculate the area where the plants are going to grow, and then you count out the number of seeds that you want to grow in that area. And once you've counted out your seeds, you're going to soak them for 8 to 12 hours. Then you're going to choose your substrate, your soil, paper towel, sand, whatever you want to grow them in. Then you're going to fill your container with that substrate. You don't need much, maybe just a centimeter. Then you add your water, and then you add your wet seeds.
Depending on the lighting conditions that you give them, they can have a completely different look and a totally different taste.
All right, so just again, kind of taking a recap there. So we're talking about popcorn that you can find in your cupboard, whether it be kind of a bottle of just kernels or Trent and Gioia. I think we said that you could cut open a bag of microwave popcorn and try it. I think the results will be mixed, but you could use even that.
Yeah, I don't see why not. Yeah, and I want to thank Christina Johnson, our wonderful NASA postdoctoral fellow, and her children for putting together that amazing video. But yeah, as long as they're unpopped kernels, they have a pretty good chance of growing.
Cool. So we're going to post more details on Twitter and other social media platforms to kind of allow you to know what you need to do. But again, it's really pretty simple there. It's pulling the kernels, finding a container to put them in, having something to plant them in. Now, Christina mentioned a few different things, and I'm sure there's a lot more creative things you could come up with. We mentioned soil, sand. I think she mentioned even just paper towels, just laying them on paper towels. That works.
Mm-hmm. Yeah, you could try an old rack, all sorts of
Right,
things.
I was going to mention that I just did it on felt. You could do it on a towel. As long as the substrate can hold water, it will allow the kernel to germinate, and the kernel has a lot of energy in it. So actually, you can grow them in the dark, so you don't give them any photosynthesis, and they're going to go looking for the light, and they'll convert a lot of the sugar into the stalk. So actually, if you grow them in light or dark, it will change the flavor, and it's pretty interesting. I would recommend that you maybe not eat it, because I grew a lot of other stuff with my kernels, but it's a part of an experiment, I guess.
Yeah, we're encouraging everyone, if you've worked in a lab, whether it be in grade school or otherwise, you know that eating your experiments is not generally a wise thing, so we're encouraging folks to not eat those products. You can send us your photos and your data. NASA at home there in the video, also there on screen now. Gioia, Trent, final thoughts from you all. Just what are you looking forward to the most in the next 5 to 10 years when it comes to plants and NASA and exploration?
Well, for me, I think it'll be, our journey going back to the moon. This is something that I haven't seen in my lifetime, and I'm really excited to have people on the moon again, the first woman and the next man, and hopefully they'll be growing plants.
Yeah, I want to echo what Gioia said. I can't wait to see the crews on the moon growing plants for nutrition, and just being part of the team that helps make it happen. That's what I'm really looking forward to.
Awesome. Well, Gioia, Trent, thanks to both of you. A quick plug for everybody out there. We're going to be posting additional social media content over the course of the next 10 days, and then we'll come back again with a couple more folks from the plant life sciences area and kind of talk about the before and after of this project. So again, Gioia and Trent, thank you to you both, and look forward to seeing your popcorn products here soon.